In this study, researchers wished to determine the ability of wild New Zealand robins to comprehend numerical and categorical congruency by assessing their actions after observing researchers either add or subtract worms from a box placed in a natural robin habitat. They hypothesized that the robins would serve as a good model for the role of evolution and numerical competence, since nothing in the experiments involved the robins learning anything. This study builds off of past research looking into avian discriminatory abilities, including a 1989 study from Honig and Stewart, which looked at pigeons' ability to discriminate based off color, form, and size, finding that the pigeons in each experiment were able to distinguish between the stimuli they were previously presented with and a distractor, although some required more trials to learn the skill than others. A major component of the study of focus here is the utilization of the violation of expectation paradigm, which in simple terms is presenting the observant with an impossible event based on what they just previously observed. The researchers of this study mention in their introduction a 1992 study which employed this technique on toddlers in order to test their responses to arithmetic operations. For the study, the violation of expectation paradigm was operationalized as a box with a trapdoor compartment, which is where the researchers placed a predetermined amount of worms unbeknownst to the robins, as displayed here. How the procedures of both the numerical and categorical congruency trials worked was first the robins were given time to get familiarized with the contents of the visible compartment of the box. Once the robins' full attention was on the experimenter, the trial event began. For both experiments, robins were exposed to 8 trial events, 4 congruent and 4 incongruent. Once the trial event began, experimenters would hold out each worm they were either adding or subtracting out in clear view for the robin for 4 seconds before placing or removing the worm, with a 10-second pause between each worm. After the experimenter finished with the worms, they would step back and allow the robins to re-examine the box, finding the trapdoor compartment with the predetermined amount of worms, and they would decide whether to retrieve an amount which is congruent to the changes the experiment just made or not. To help, here are the tables provided in the study depicting example congruent and incongruent conditions. For instance, in the first experiment, if there was already 1 worm in the visible compartment, and the experimenter placed 1 worm in, then the robin would need to retrieve 2 worms from the trapdoor compartment in order to be congruent or a successful trial. Any other amount would be incongruent. How the second experiment differs from the first is the addition of another kind of worm. Robins in the second experiment would observe the addition and subtraction of mealworms and waxworms. So for instance, if there was already 1 mealworm in the visible compartment, and the experimenter added 1 waxworm, then the robin retrieving anything except 1 mealworm and 1 waxworm would be considered incongruent. The behaviors being measured in both experiments were how long the robin spent examining the box after the experimenter manipulated it, as well as how many pecks it gave it. Overall, the robins measured higher on average on the incongruent trials than the congruent trials. The averages for the incongruent trials, as depicted by this figure, in the first experiment were 42.96 seconds and 6.82 pecks, in comparison to averages of 23.39 seconds and 1.25 in the congruent trials, and in the second experiment, the averages were 52.9 seconds and 4.93 pecks, and 27.07 seconds and 1 peck, respectively. What these results tell us is that the robins in general take more notice to an impossible event than an expected event. Given that there were significantly more pecks for the incongruent trials, it is believed that the robins were processing the information there more intensely, and therefore could be completing the addition and subtraction processes mentally, a sign that the hypothesis could be further proved with future research. Thank you for watching. I hope this presentation was informative and fun.